Good morning everyone. Now let us see the statement of Bayes theorem. So now in the last video we know the definition of a conditional probability. We know the definition of conditional probability is an event A is said to be conditional probability. It means the event B is already happened. So it means that the happened event we are going to write in the denominator that we observed in the last video. Now let us see the statement of Bayes theorem is if E1, E2 and so on n are n mutually disjoint events, okay, such that P of A is not equals to 0, then for any arbitrary event A is subset of union I is equals to 1 to n E and P of A greater than 0. Then we are going to prove that P of EI given A is equals to P of EI into P of A given EI by summation I from 1 to n P of EI into P of A given EI. This is what we are going to prove. Now let us see how to prove this statement. So in the given statement they mentioned clearly what is that given A is a subset of union I is equals to 1 to n EI. So if anything is subset, then we are going to write it as now A intersection of union I is equals to 1 to n EI. A intersection union I is equals to 1 to n EI. So now let us see here what is the value. I will go with some example which is having the elements. In the given statement it contains E1, E2 and so on en or n events. So now let us see here. I am going with a small example. Let us take with the set of elements E1 is 1, 2 and the set E2 is having the elements of 3, 4 and E3 is having the elements of 5, 6. We consider the n sets are 3 sets in the given theorem statement. Now what we are going to define here, union I is equals to 1, 2, 3 EI is equals to 1, 2, 3, 4, 5, 6. Right? So now what mentioned here in the statement, A is a subset of union I is equals to 1 to n EI. So A is subset means can I take whatever the element of A in the events A is equals to, suppose if I am taking A is 1, 2. So what happened here now, A intersection union I is equals to 1 to n EI. What is A set now? We take here it is 1, 2 intersection of what is EI sets now? 1, 2, 3, 4, 5, 6. This is equals to what is the set now? 1, 2. What is the intersection set? This is equals to set A only. Right? So now let us see here. A intersection union I is equals to 1 to n EI is equals to A only as per the example. Okay, so now apply probabilities on both sides. What happened here? Probability of A intersection union I is equals to 1 to n EI is equals to A. Okay, probability of, so the same thing we know axioms of probability, 3 axioms of probability. What are the 3 axioms of probability? I am reminding one more time. P of A is greater than or equals to 0. Sum of all the probabilities is equals to 1. And third is if A and B are 2 disjoint sets, then P of A union B is equals to P of A plus P of B. So now we are going to write it as union set. So it means like that P of union I is equals to 1 to n A intersection EI is equals to P of A. So before the concepts we learned De Morgan's laws. So now let us see one more time by De Morgan's law. What is De Morgan's law here actually? So this is what? P of A intersection of B intersection C. If you are having 3 events, so how to write the 3 events now? P of A intersection B which is having the elements of union of the 2 elements. Union of A intersection C. Or you are going to like in this way or not? Whenever you are having 2 events now. If you are having 2 events now, A intersection E1 union A intersection E2. The same thing, the way what we are going to write it as now, union I is equals to 1 to 2 because we are going to write 2 events, right? So this is equals to what? P of A intersection EI. So the same thing now we are going to write it as probability of union I from 1 to n A intersection EI is equals to P of A. because here in the given statement we are taking E1, E2 and so on, En or n mutually disjoint events in the given statement, right? So now let us see here P of union I from 1 to n A intersection A. We know the third axiom of the probability. What is the third axiom of the probability? Now let us see by third axiom of probability. By third axiom of probability, what happened here? This is equals to probability of union I is equals to 1 to n AI is equals to sum of all the probabilities, right? So this is equals to what? Summation I from 1 to n P of A. Okay, so the same thing we are going to write it as summation of P of, how to write this is A intersection EI. P of A intersection EI is equals to P of A. And we know the conditional probability definition. The event which is already happened, we are going to write it as in the denominator, right? So now let us see here by conditional probability. How to write here by conditional probability? Summation of P of EI into P of A given EI. P of A given EI is equals to P of A. Let us see here, it is an equation 1. It means that how to write this equation? The event A is already happened. The event which A is already happened. So now let us see the exact definition of conditional probability. How to write here? By definition of conditional probability. By definition of conditional probability. How to write here now? P of A intersection EI. Okay. P of A intersection EI is equals to, how to write? P of EI into P of A given EI. Let us see this as equation 2. So without any confusion, I would like to continue in the same page. Now let us see here, you are going to write equation 1 and 2. The same equation 2, how to write again? Here you are going to write the event A is already happened. The same statement you are going to write, the event A is also already happened, right? So now how to define this? P of A intersection EI is equals to P of A into P of EI given A. What happened here? The same thing you are writing. The second statement you are going to write the event A is already happened. The same definition you are going to write the event A is already happened. Okay. So what we are going to prove now? P of EI given A is equals to, what is P of EI given A is equals to? From this, how to write P of EI given A? P of A intersection EI by P of A. Okay, so now substituting the equations 1 and 2 in this statement. Okay, so what happened here? Let us just substitute 1 and 2 equations. Substitute 1 and 2 here. What happened here? P of EI given A is equals to P of A intersection EI is equals to, how to write P of A intersection EI? P of EI into, how to write P of EI into P of A given EI, right? So substitute in the equation 1 here, denominator, what is P of A? Summation of P of EI. Summation, how many elements? You are taking n elements. So you are going to write summation of P of EI into P of A given EI. Okay. So now the Bayes theorem is proved. Okay. So the problems are also in the same way. The given problem, it contains, you are having n elements. You have to identify first how many number of elements are there in the given problem. What is the success event are there in the given problem? The event is happened. It means the success event or the item is to be defective. You are going to finding out the element whatever we are having, and we count the conditional probabilities based on Bayes theorem. Now let us see the problem on Bayes theorem. So we discussed earlier, Bayes theorem means we learned the statement if E1, E2 and so on, En are n mutually disjoint events such that probability of A is not equals to 0, then for any arbitrary event A is subset of union I is equals to 1 to n Ei. What do we learn the statement there? P of Ei given A is equals to P of Ei into A given Ei by summation of P of Ei into A given Ei. So it means that the theorem is completely based upon the conditional probability. So in the last videos we learned the definitions of a conditional probability, that is an event A is said to be conditional probability. It means that the event B is already happened. So the same thing we are going to define in the notation, the event, which event is already happened, that event we are going to write in the denominator. So now let us see the problem. So how to identify the problem is based upon the conditional probability. A success event is there in the problem or a defective item is there in the problem. So now we are going to define. In a class it is known that the probability of a girl getting first class is 0.25 and that of a boy getting first class is 0.28. So before going to solve this problem, how many events are there in the problem? So it is only of 2 events. So what are the 2 events? So in the what we discussed here, actually whatever the events, E1, E2 and so on, En or n events. Now in the given problem you are having 2 events. So that 2 events we are going to define it as E1 and E2. So let E1 and E2 are the events of boys and girls, or the events of boy and girl. This is what we are going to define. So now let us see here, what is the probability of getting a boy? Suppose we are having 2 urns. The probability of getting first urn is only 1/2. The probability of getting today is a rainy day. So what we discussed earlier. So if it is a dry day, the favorable case is 1. So it will be 1/2. So the probability of getting a boy out of 2 people is P of E1 is equals to 1/2 and P of E2 is equals to 1/2. What is a success event in the problem? So A is the event of getting first class. Now let us see here, A is the event of getting first class. A is the event of getting first class. So it means the event which is already happened or a success event. If any defective item is there, the event is already happened. So now the thing is, here we are in the given problem, we are going to define A is the event of getting a first class. You know that P of EI given A is equals to is a Bayes theorem. So it means that based on that we are going to write the events. So what is the events? So you are going to write it as A given E1. What happened here? E1 is what? The probability of event of selection. It will be a boy and he is getting a first class. A given E1. So now let us see here. It is known that the probability of a girl getting first class and boy getting first class. So what happened here? We are going to define A given E1 and P of A given E2. So what happened here? E1 or E2 are the events of boys and girls. So what is of boy getting first class? 0.28. What happened here? E1 is the event of getting a boy and he is getting first class. E2 is the probability of getting a girl. The event is already happened and she is getting first class. So girl getting first class, it will be what? 0.25. We define 2 events. Now the thing is, we are going to finding out what? Find the probability that the student chosen at random will get the first class and it is a girl. Okay. So what we are going to finding out now? Probability of E2. So what is girl event? We are going to define it as E2. E2 given A. What happened here actually? The girl will get the first class. The person will get the first class and it will be a girl. Okay. So P of E2 given A is equals to, what is the formula now? P of E2 into P of A given E2 by summation. How many events we are having in the problem? 2 events are there. That is what? Summation I is equals to 1 to 2 P of EI into P of A given EI. So here I refers to whatever the number of events are there in the given problem, that number of events we are going to add in the denominator. So what happened here? We are going to finding out only girl event getting first class. This is what? P of E2 into P of A given E2 by sum of the events. So first event, what is first event here actually? P of E1 into P of A given E1 plus P of E2 into P of A given E2. This is what we are going to finding out, right? So now the thing is, we are going to finding out P of E2 given A. What is P of E2 given A? What is P of E2 here? 1 by 2 is 0.5. A given E2. What is A given E2 here is 0.25. So 0.5 into 0.25. So what next here? E1 into A given E1. What is E1 here actually? E1 is 0.5. A given E1. What is A given E1? 0.28 plus E2 is 0.5 into A given E2. What is A given E2? This is what we are having, 0.25. So simplify this. We are going to finding out what is 0.5, 0.12, 0.25. So it will be 0.125. 0.5, 0.28. It is what? 0.14 plus again 0.125. So you have to add these probabilities. So this it will be equals to 0.125 by 14 plus 125. It will be 0.265. So the required probability is equals to 0.4716 is the required probability. Now let us see the next problem on Bayes' theorem. The chances of XYZ becoming managers of a certain company are 4:2:3. So it means that what is the total ratio of here? The thing is we are going to finding out 4 plus 2 plus 3 is the total number of outcomes. The probabilities that the bonus scheme will be introduced if XYZ become managers, they have the probabilities are 0.3, 0.5 and 0.8. It means that when the bonus scheme has to be introduced, so it means the event is already happened. So now what happened here in the given problem? Let us see the solution. How many events are there here? 3 events. The 3 events, how to define it as? Let E1, E2, E3 are the events of XYZ managers, or the events of XYZ managers. Now the thing is what? We are going to finding out what is P of E1, what is P of E2 and what is P of E3. Now let us see here. As per the given data, what is P of E1? So it is what? 4 plus 2 plus 3. 4 plus 2 is 6. 6 plus 3 is 9. So P of E1 is 4 by 9. And P of E2 is what? 2 by 9. And P of E3 is what? 4 by 9. So the event which is already happened, the success event is there in the given problem. What is the success event in the problem? The bonus scheme has been introduced. So what we are going to define? Let A be the event of introducing a bonus C. Let A be the event of introducing bonus scheme. Let A be the introducing bonus. So what happened here? This is nothing but we are going to define A given E1. What is A given E1 value? 0.3. And probability of A given E2, what is the value? 0.5. And P of A given E3 value is what? 0.8. It means these are we are going to write on the form of conditional probability. What happened here? The event E1 is already happened. It is having with the manager of X1 achieving bonus scheme. Okay, so like this is the meaning of A given E2. E2 is the manager of Y having getting bonus scheme. E3 is the manager of Z getting bonus scheme A is, that is 0.8. Now what is the thing they are asking in the given problem? If the bonus scheme has been introduced, what is the probability that X appointed as a manager? So what we are going to finding out now? P of E1 given A. So what is E1 given A? X appointed as a manager. A appointed as a manager introducing the bonus scheme. It will be of E1. What is E1? X. E1 be the event of X. So now the thing is we are going to finding out probability of E1 given A. So what is the formula of E1 given A? Probability of E1 into probability of A given E1 by the sum of how many events in the given problem? Summation I is equals to 1 to 2 P of EI into P of A given EI. So how to split these values here? The denominator it will be what? P of E1 into P of A given E1 by. So substitute here first as I place as 1 and then next I place as 2. So what happened here actually? P of E1 into P of A given E1 plus P of E2 into P of A given E2. So now let us see here what is P of E1 in the given problem. P of E1 is equals to 4 by 9. P of A given E1. What is P of A given E1? This is what? 0.3. The denominator, we are adding these two values. What is the two values again? P of E1 is what? 4 by 9. Okay. So how many events? X, Y, Z also there. So it will be I is equals to 1, 2, 3. So you have to add one more event, that is what? P of E3 into P of A given E3. Right? So now let us see here the denominator I from 1 to 3. What is first event? E1 is what? 4 by 9. 4 by 9 into what? 0.3. Okay. Next P of E2. What is P of E2? 2 by 9 into A given E2 is what? 0.5 plus third event is also there. We added the third event. P of E3 is what? 4 by 9 into A given E3. This is what? 0.8. So now you have to multiply these values. This is equals to, it will be cancelled 0.3 times 1.2. The denominator it will be 1.2 plus 1.2 plus 1.0 plus 2.4. Now let us simplify this 1.2 by 4.6. The solution it will be 0.26. We know that the probability lies between 0 and 1. So this is the way we are going to conclude the solution of Bayes theorem problem. Now let us see the next problem. There are 3 urns having the following compositions of black and white balls. We are having the combination of balls as black and white. You are having 3 urns which is having the combination of black and white balls. Now one of these urns is chosen at random with the probabilities. So how many probabilities they are giving? We are having 3 urns. 3 urns is having with the different probabilities. So it means that how many given events are there in the problem? Let E1, E2, E3 are the events of 3 urns. Or the events of how many urns? Or the events of 3 urns. So which is having with the probabilities of what? P of E1. P of E1 is equals to 0.2 and P of E2 is equals to 0.6 and P of E3 is equals to 0.2. So it means that from the choosing on 2 balls are drawn at random with replacement. With replacement, we are taking some ball, again we are not keeping that in the same place. So calculate the probability that both these balls are white and also calculate the chosen on 1. So now the thing is, we are going to finding out A given E1. A is the event of choosing the ball, it should be white. Okay, so now the thing is what we are going to finding out here? P of A given E1. What is P of A given E1? From the choosing on 2 balls are drawn, each choosing on. So it means that the on 1 is selected and it should be white. That white but must be 2 balls are to be white. So how many on 1, how many white balls? We are having 7 balls. Out of 7 you are choosing 2 balls. So it will be how many number of ways? It will be 7C2 by, because we are selecting only the number of balls out of total balls. Okay, selecting 2 white balls out of 7 balls. So now total number of balls are how many? 7 plus 3, 10. So 7C2 by 10C2. So we know the value of the formula NCR is equals to n factorial by r factorial into n minus r factorial. So we are going to finding out this is a value of 21 by 45. In the same way, we are going to finding out what is the next value? P of A given E3. So what P of A given E2? What is P of A given E2? On 2 contains how many white balls here? 4 white balls. Out of 4 white balls, you are selecting 2 white balls. So how many ways you are going to select? The total number of ways of selecting 2 balls out of 4, it will be 4C2 ways. So here what is P of A given E2? 4C2 by now 4 plus 6, it will be how many? 10C2. We know the denominator we are calculating it is here 45. So 4C2 is what's the value of 6 by 45. In the same way, we are going to finding out A given E3. Okay. So now here A given E3. What is E3 is nothing but on 3 we are selecting 2 white balls. Out of 2 we are selecting 2C2 by 2 plus 8 again it is 10C2. So what is P of A given E3? It will be 1 by 45. So what is the first thing we are going to finding out now here? Actually P of A value. Why it is P of A? 0.2, 0.6 respectively. From these, choosing on two balls are drawn at random, calculate the probability that both these balls are white. Both these balls are white. White means here we are going to define A is the event of selecting a white ball. So what does it mean? We are going to finding out P of A only. So what is P of A here? Actually P of A is equals to sum of how many elements are there? We are having 3 ons. 3 ons is having different probabilities. So it will be what? Summation I from 1 to 3. Okay. So it will be what? P of EI into P of A given EY. You just expand this. I refers to the values of 1, 2 and 3. So now let us see here what we are having. P of A is equals to P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. Now the thing is, we already know down all these values whatever we are having. So now just substitute the values and simplify your solution. What is P of E1 here? 0.2 and A given E1 is what? 21 by 45. So now here it will be 21 by 45 plus what is P of E2 is here? P of E2 is what? 0.6 and P of A given E2 is 6 by 45 plus what is the next one? P of E3. What is P of E3 here? 0.2. A given E3 is 1 by 45. So now in order to simplify this, you can take a common term as 1 by 45 of all the values. Now let us see here. Take the common term of 1 by 45. 0.2 into 1 it will be 4.2. 0.6 into 6 it will be 3.6. Now let it be here 0.2. So now what is the solution of here? It will be of 8 by 45 is equals to 0.174. Now let us see the next problem. What is next problem? Your problem is not at all completed. Calculate the probability that both these balls are white. This is what we are finding out now, P of A, and also calculate the chosen on 1. The ball should be drawn from the on 1. So what we are going to finding out now? P of E1 given A. What happened here? The ball it should be white and it should be drawn from the chosen on 1. So you are applying the event conditional probability is there. So here E1 given A is equals to what? We are going to define it as P of E1 into P of A given E1 by. We already finding out what is P of EI. Here it is what? Summation I from 1 to, the given problem contains 3 elements. So summation I from 1 to 3 P of EI into P of A given EI. This is what already we are finding out in the solution of the first problem, right? So what it will be? P of E1. What is P of E1 here? 0.2 into P of A given E1 is 21 by 45, and here this denominator we are getting it as 0.174. So it will be, you have to cancel this term, it will be becomes of 4.2 by the denominator it is what? 0.174. So it will be, now we can write the solution. So now let us see here. So A given E1. So now let us see here. P of A given E1 is 21 by 45 plus P of E2. So P of E2 is 0.6 into A given E2 is 6 by 45 plus P of E3 is what? 0.2 into A given E3 is 1 by 45. So now taking the common term of all these is 1 by 45. So now it will be what? 0.2 into 21. So you have to multiply, it will be 4.2 and 0.6 into 6 it will be 3.6 and now it will be 0.2. So this probability is equals to 8 by 45. It will be 0.174. The second problem is what we are going to do. You are going to finding out, calculate it from the chosen on 1. What is chosen on 1? P of E1 given A. What is P of E1 given A? P of E1 into P of A given E1. P of A given E1 by summation of P of EI into P of A given EI. Now this denominator you already find out in the first solution, right? So now what is this? P of E1 is what? P of E1 is what? 0.2 into P of A given E1 is what? 21 by 45 into here this denominator it will be 8 by 45. Now simplify this, you will get the required probability is 0.517 is the required probability of the Bayes theorem.